So AgMIP is the Agriculture Model Intercomparison and Improvement Project, which is one of the largest research networks in agriculture, which brings about 1,000 different scientists together across the globe, trying to better understand how climate change impacts agriculture and how we can adapt to it. So it started about 8 years ago, goes across about 30 different projects, and has put teams together for the major crops like wheat and rice, maize, and we just started one on soybean. Some of the crops, and for instance barley and lentil, have no teams yet. And I think it would be very important that we find a leader who wants to lead such a project within AgMIP, and then motivate the community, whoever has a barley model, whoever has a lentil model, to come together, work together on the models, and work together with experimentalists to build this. So I would really encourage ICARDA maybe to lead one or both of these crops, to bring the community of crop models together and repeat some of the experiments, some of the intercomparisons we've done, which really helped us to better understand how some of these crops are modeled, and also helped us really understand what is climate change impact on these crops, which would be also very important for barley and lentil. I think it can. Climate change will affect all different agriculture systems, which are where we grow crops under the open. We will see definitely changes in CO2, which will go up. The temperature will go up in many of the agricultural regions. In dryland agriculture, rainfall is another important component which causes part of the largest variability within dryland agricultural systems. And in some areas, rainfall goes down and others goes up. Often we see an intensification of rainfall events. So understanding of how climate change will affect not just CO2, temperature and rainfall. Also rainfall will be very important to really help to understand what will be the impact of climate change. Some of these impacts we start to see already, but it will also help us to prepare for the future in terms of climate change in these particular regions, in the dryland agriculture region. If we get longer periods of drought, we need to be prepared for that. We need to start breeding for cultivars which can deal better with it. If in most regions we see an increase in temperature, we need to think about how we get crops or cropping systems into place which can better be adapted to higher temperatures. So again, understanding climate change, the scenarios for the next 20, 30, 40, 50 years are very important to help farmers preparing for decisions, to prepare them for the changes which are going to come through climate change. So seasonal forecasting is sort of a relatively new discipline in science, where we try to understand the next few months, maybe up to 6, up to 9 months of weather, climate, most of the time in terms of if it gets wetter or drier, if it will be hotter or cooler in the next season. Having this information gives the farmer new ways to sort of prepare for that. If you know you have a dry season, then you might change your crop. You might actually put less fertilizer on there because you only expect a small crop. If you have a forecast for a good season, often referred to having more rainfall, for instance, in dryland agriculture, you might need more fertilizer. You might actually expand your cropping area to take advantage of that. So using seasonal forecasts could be very important for right now, if you have it, if it works, to help farmers to manage climate variability. And dryland agriculture, rainfed agriculture, is characterized by huge variability between dry and wet years. But it even becomes more important in the future with climate change, where we will have more poor seasons. We have to make sure to give farmers the tools to recognize the good seasons, to get most out of it, and be prepared again for the poor seasons, to reduce the inputs, to adapt to it, to not wasting limited resources in seasons where the yields will be very poor. So seasonal forecast is one of the biggest areas, I think, in agricultural research to really help farmers now, but maybe more likely even in the future, to deal with seasonal variability.